various documents. I think I put up some more recently. I made an announcement to that effect. Yes, antiderivatives. This is too loud. I put up antiderivatives, L'Hopital's rule, and applied maximum minimum problems. For those of you who are focused on part 2, you should be sure you can do that stuff. Okay? You should be able to do the curve sketching, the related rates. Where else? Curve sketching, related rates, applied max min, L'Hopital's rule, antiderivatives. Do you do that with the accent for Christine? Okay. And implicit differentiation. All right. We will have mock final practice problem stuffy up before the end of the week. Okay, on the official web page. Okay, and somewhere in here we'll have sample final exams plus. I don't know when the solutions will go up, but we'll put them up before the final. I wrote the rough draft of the final, but Professor Sutherland will give it the massage, and between the two of us, we'll have the final, okay? So, I have a pretty good idea of what's on the final. Well, you know, he's in charge, of course. So, I said, how about I write a rough draft? He said, great, so I wrote a draft of the final. He said, this is much too easy, it won't be enough time. No, I'm kidding. We're not trying to make it hard, but we want to make sure you guys are ready for 126. That's the idea. Okay? So there we go. Stuff you should be able to do. Let's see if you guys can do those derivatives. And on part 2, what will happen is the problem will still require you to be able to take derivatives. You'll just have to do something with the derivatives. Okay? Who can't read my handwriting? That says tangent of 3x, but you can make it a 2x if you want. That says tangent of 3x plus tan inverse of 5x. That's long enough. Let's practice our derivatives. F prime of x. You do low d high minus high d low. You guys should be bored with this by now. Low times the derivative of the high, which is 2x plus 3, minus high, times the derivative of the bottom, which is 15x squared, over bottom squared. Now, we might ask you to find f prime at 1, or f prime at 0, or f prime at 2. Then you'd have to plug in, okay? But otherwise, you could just leave it like that. So many of you messed up on this, because when you plugged in, I think it was at 0 or 1, you just didn't plug in properly. So then you redid it, and then you just did the WebAssembly, then you did the quotient rule totally wrong. Have some faith in yourselves. And as I just heard, some of you got it wrong because you had capital X instead of lowercase x. or you put in the wrong letter. Don't use t if it's x, don't use x if it's t. Pay attention to that stuff. Okay? Alright, derivative of this. Derivative of tangent is secant squared. So this is secant squared of 3x times 3, because you have the chain rule. Okay? What happened to my plus sign? Plus. There was a plus sign there. You want to do it as product rule? We can do it as product rule. Sure. I'll leave it as product rule. That's fine. Tan inverse of 5x plus, okay, tan of 3x times the derivative of tan inverse of 5x. What's the derivative of tan inverse of 5x? Okay. 1 over 1 plus 5x squared times 5. Many of you will put 5x squared but not put 5 in parentheses, or will not multiply by 5, or put a square root that just doesn't belong there. Okay? So remember, what's the derivative of tan inverse of x? 1 over 1 plus x squared. So if this is 5x, that's 5x parentheses squared. What's the derivative of sine inverse of x? 1 over the square root of 1 minus x squared. So if it was sine inverse of 5x, you'd have 1 minus 5x parentheses squared. Then you have to multiply by the derivative of 5x, which is 5. Okay? Good? Bad? Love and life? Not so much? Okay? What's the derivative of the square root of x? Well, you could write this as 1/2 x to the minus a half. Or you could have memorized that it's 1 over 2 root x. I recommend memorizing that. It makes life easier. And the derivative of 2 over x, you do not use the quotient rule. Many of you use the quotient rule on that, and then you get it wrong. Okay? The derivative of 2 over x, well, this is the same as 2 times x to the negative 1. Right? 2 over x is 2 times x to the negative 1. So the derivative would be negative 2 x to the negative 2. Or 2 over x squared. So you could leave it like this. Okay. What's the derivative of log of 4x cubed? Answer the question. You just were playing with the hair. Okay. This is 3 times log of 4x squared. What's the derivative of the natural log of 4x? 4x on the bottom, 4x on top, 4 on top. I've got the plus sign again. This is crazy. Alright. I don't love product rule this much. Okay. The derivative of the natural log of 4x, 4x on the bottom, 4 on top. What's the derivative of the natural log of 4? It is not 1 over 4. It's right. It's not 1 over 4x. It's not 4 over 4x. It's 0. Why is it 0? Because the natural log of 4 is a number. It's a constant. Okay, it's about 1.1. What's the derivative log of 4? 0. Okay? We good? So far, so good? Okay. Let's make it more fun. Find the equation of the tangent line to y equals 3 sine 2x at x equals pi over 6. Are we ready? Do we need another 30 seconds? Are we ready, Anisha? Okay. So first, we're going to need the y-coordinate. Remember, when you do the tangent line, y minus y1 is slope times x minus x1. So we need the slope, and we need a y-coordinate, because we already have the x-coordinate, that's pi over 6. So you get the y-coordinate, you plug in pi over 6. And y1 is simply the 3 sine 2 pi over 6. Well, we know what the sine of 2 pi over 6 is. It's the sine of pi over 3, and you've all memorized the unit circle. That's 3 radical 3 over 2. Now we have to get the slope. To get the slope, we take the derivative. Y prime is going to be 3 cosine 2x times 2, or 6 cosine 2x. Now to get the slope, we have to plug in pi over 6. So it's 6 cosine 2 pi over 6. Cosine of pi over 3 is half. So this equals 3. So now the equation is y minus 3 radical 3 over 2 equals 3 times x minus pi over 6. Okay? Let's do some more. Then we can do some of the good stuff. Beth, you had one. Find f prime of t, where f of t equals 4/5 t to the 5th minus 3t to the 4th plus 8t plus e cubed. Or close enough. That's long enough. You should be able to take those derivatives. Okay. 4/5 t to the 5th. By the way, many of you do not seem to realize that this is the same as this. You don't need to use the quotient rule here. But if you're going to do the quotient rule, the derivative at the bottom is 0. You don't leave it out. When you leave it out, you get it wrong. You don't do this. You have to put the 0 in so that it cancels this. And then you say, oh, right, I didn't need to do the quotient rule after all. Okay, if you do the quotient rule and one of the two parts of the quotient is 0, then you didn't need to do the quotient rule. All right? So here, the derivative is 4t to the 4th minus 12t cubed plus 8, because what's the derivative of e cubed? 0. What's the derivative of log of 3? What's the derivative of pi? Good. All right. This one is 5 times this stuff to the 4th, so you leave that alone, times the derivative of the inside. which is 3x squared minus 6 over 2 root x, plus 0. Some of you, when you did this, you forgot these parentheses. That is incorrect. Okay? Order of operations, that is incorrect. You have to do this. Okay? If you do not do that, you get it wrong. Okay? Good. Now let's do some of the newer stuff. Okay, on part 2 of the final, you might be expected to graph a function. So why don't we see if you can graph that? All right, I've had enough of this one. You ready? So when you want to do graphs, you need to do two things. You need the first derivative, you need the second derivative. So the first derivative, y prime, is negative 12x squared plus 36x plus 120. And the second derivative is negative 24x plus 36. Now we have to find where these are 0. So we're going to take negative 12x squared plus 36x plus 120 and set it equal to 0. If you divide by negative 12, you get x squared minus 3x minus 10 equals 0. And does that factor? Why, yes, it does. Oh my gosh. X minus 5 and x plus 2. So our critical values are x equals 5, x equals negative 2. So if this is a 10-point question, when you get to here, you're about 4 points in already. Okay? Now you set the second derivative equal to 0. And you're going to get x equals 3/2. Okay? Now you're probably about 5 points in. So you're doing okay at this point. Alright? Remember, it's all about the partial credit. Alrighty? Now, let's look at the first derivative and see where it's increasing and where it's decreasing. So you pick some numbers. You pick a number less than negative 2, like negative 3. You plug it into the derivative, and you get negative 108 minus blah, blah, blah. This is going to be negative. You plug in a number like 0, and you get positive. You plug in a number like 6, and you get negative. So your curve is going down, then it's going up, and it's going down. So that's a minimum, that's a maximum. Yes? You have to be careful. If you plug into the factor equation, you'll lose the minus sign, because you have a minus sign up here. So if you're not sure, leave the minus 12 out there, okay? Does that help? So that'll help you get the sign correct. I messed that up a lot too. Yes? I can't hear you. That's 3 over 2. You put the 24x on the other side, and you get 24. Okay? So far, so good? Alrighty. Now we have to do the second derivative. You try a number like 0, you get 36, that's positive. You try a number like 2, and you get negative. So it's concave up here, concave down here, which kind of matches that. Okay? So you have a point of inflection at 3/2. So now you know that you have a max at x equals 5, a minimum at x equals -2, and a point of inflection at x equals 3/2. Now you have to find the y coordinates. This is when you're happy you have scrap paper. You take 5 and you plug it in, and you get 542. Is that right? Tell me if I'm wrong. I don't know. You just trust me on that? Okay. I could be wrong. Plug in -2 and you get 32. Minus 72 is plus 72 is 104. Minus 240 is minus 136. Minus 144. Is that right? Maybe you did the calculator? You're saying yes, but is it right? Maybe we're both wrong. Okay. And then you plug in 3/2, which I'm not going to do in my head, and you get something. All right, I'll do it in my head. What? 199. All right, we're going to trust you because you have an electronic device that you're holding up. All right. So now we graph this. We know we have a y-intercept at -8, by the way. All right. We have a maximum at minimum at -2, -144. We have a maximum at 5, 542. And we have a point of inflection at 3/2, 199. And you get one of those. Okay? Should we do another one of these? All right, let's make you graph something more annoying. Okay. Once we put in the e, we lose half the room. Yes. Oh, that's the y-intercept. The -8 is, you don't need it, it's the y-intercept. Okay. So you want to know where the -8 came from? Yes. Hey, find the y-intercept. Plug 0 into the original equation. And the constant was 8, so that's the y-intercept. Okay. All right, should we do this one as a team? Alrighty, let's take the derivative. What's the derivative of e to the minus 4x squared plus 1? It is e to the minus 4x squared times the derivative of minus 4x squared, which I like to put in front, but you don't have to. Okay? And the derivative of 1 is 0. So that was kind of an easy derivative. All right, now for the second derivative, we need the product rule. So we could do negative 8x times the derivative of e to the minus 4x squared, which is minus 8x e to the minus 4x squared. Plus derivative of negative 8x, which is negative 8 e to the minus 4x squared. Alright, let's find where these things are 0. So the first one, negative 8x e to the minus 4x squared equals 0. What's the important thing to remember about the exponential function, about the e term? It's never 0, it's always positive. So this part is always positive. So you just care where is negative 8x equal to 0 at x equals 0. So that's going to be our critical value. Good? All right. Now we take the second derivative and set it equal to 0. So this cleaned up a bit. This was 64x squared e to the minus 4x squared minus 8 e to the minus 4x squared. So we could factor out e to the minus 4x squared, and we'd be left with 64x squared minus 8. When you have one of these exponentials, they can factor out very nicely. And remember, the e term is never 0. So 64x squared minus 8 has to equal 0. So you get x squared equals 1/8, or x equals plus or minus the square root of an 1/8. So far, so good? Any happy faces? Anyone? Alright. So let's see. We have to do some sign testing now. So let's test the first derivative. We try a number less than 0, like negative 1. You get 8 times something that's positive. So it's positive, so the curve is going up. Try a number bigger than 0, like 1. You get negative 8 times something positive. So this is negative, so the curve's going down to the maximum at x equals 0. Alrighty. Let's do the second derivative. We've got negative square root of an 8th and positive square root of an 8th. So let's try some values. How about negative 1? This is always positive. 64 minus 8 is positive. So we're concave up in this region. Try a number between negative and 8 and negative square root of an 8th and positive square root of an 8th, like 0. This is positive. 0 minus 8 is negative, so it's negative, so concave down here. And then let's try a number bigger than an 8th, like 1. This is positive, and this is positive, so it's positive, so it's back to concave up. Anything else we know about this graph? What's the limit as x goes to infinity of that graph? By the way, as x goes to infinity, this is 0, so you can get 1. When x goes to minus infinity, this is 0, so you can get 1. Why is it 0? Because that's 1 over e to the 4x squared plus 1. So 1 is going to be a horizontal asymptote. That might help with the graph. Might not. Okay, so we have 2 points of inflection. We have one at x equals the square root of an 8th, and one at x equals negative square root of an 8th. So now we have to find the y values. So this is the kind of, this will be a hard question of the exam. Really? So when you plug in 0, that's 1. Plus 1 is 2. When you plug in the square root of 8, you get 1 over e times 4 times an 8, which is e to the half, plus 1. So you get 1 plus 1 over the square root of e. And same with the negative. And then we graph it. And you get that. You get the bell curve. That's the point 0, comma 2. That's the point square root of an eighth, comma 1 plus 1 over the square root of b. And that's negative square root of an eighth, comma 1 plus 1 over the square root of b. So if I were doing this on an exam, this would be of minimal value, okay? The important thing is to get the shape of the graph right. I don't really care about that. Recognize it has a horizontal asymptote of some value. Whenever you're doing graphs, you should always test the limits. See what's going on at plus and minus infinity. Okay? Let's do one more graph and then you'll have enough for one day. Do this as a team, so I don't run out of time. I just have to get the makeup at 5:30. Let's take the derivative. So y prime is 4x cubed minus 8x, and y double prime is 12x squared minus 8. So we set these equal to 0. 4x cubed minus 8x equals 0. You can factor out on 4x. You end up with x squared minus 2. And you get x equals 0, x equals plus or minus the square root of 2. Okay. And for the second derivative, we set that equal to 0. 12 x squared minus 8 equals 0. You get x squared equals 8 over 12, also known as 2/3. So x equals plus or minus the square root of 2/3. So let's do some sign testing. Okay. I want 0. So you try a number less than negative square root of 2, like negative 2, and that comes out negative. Try a number like negative 1, and it's positive. Try a number like positive 1, and it's negative, and positive 2, and it's positive. So the curve is going down, up, up. So it's a min, a max, and a min. Second derivative. We put in negative square root of 2/3 into square root of 2/3. So try a number less than the negative square root of 2/3, like negative 1, and that comes out positive. Try a number like 0, you get negative, and then positive again. So we have 2 points of inflection where it goes from concave up, to concave down, and from concave down to concave up. Now we need the y coordinates. So the max at x equals 0. We have mins at x equals square root of 2, negative square root of 2. And with points of inflection at x equals square root of 2/3 and negative square root of 2/3. Alrighty, now to come up with the y coordinates. Well, squaring these things is easy. Let's see. When x equals 0, y equals 1. When x equals the square root of 2. Square root of 2 to the 4th is 2 squared is 4. Square root of 2 squared is 2, so you get 4 minus 8 is minus 4, plus 1 is minus 3. Same here. And at the square root of 2/3, You get 4/9 minus 8/3, which is minus 27/9, is minus 23/9, plus 1 is minus 14/9. There you go. That's what the graph looks like. Now I have a question. How many of you do not need to take Math 126? So that's it. So you don't have to take any more math after this. So first grade, second grade, high school, this is it. One more math class for the rest of your lives. How exciting is that? I knew you'd be happy. It makes me feel a little warm knowing that, you can forget the unit circle in exactly a week and 2 days. That's so awesome for all of you. See you on Wednesday.